Sorting data is an incredibly important thing to do when you're working with lists of information because, as we've seen, you can make all of your processes more efficient by dealing with a sorted collection instead of an unsorted collection. So in this program, we are going to learn a sorting algorithm called selection sort. So the way selection sort works, there's a lot of different ways to sort information. It's going to find the smallest item in the unsorted collection and add it to the end of the sorted collection. So what we're going to be doing is we'll be having a random array, and then we're slowly going to build a sorted version of that information. So what would happen here is 5 would get removed and added to the end of our sorted information because 5 was the smallest item that was in that array. So what we're going to do is we'll have to, of course, use vectors. So we're going to include the vector library, and we are going to include the time library. Okay. Now we'll go to the main program, and we'll start with a vector, and we'll just call it n. We'll call it numbers, just to create a little bit of a distinction here. So numbers, and that's going to be an empty one. And then what we'll do is we'll create a function called load random, and then we'll do numbers, comma 20. We will do 20 numbers in that array. Now, at the top here, we'll create that. So void load random. And then in this one, we're going to have a vector. We'll put an and sign n to make sure that it's being passed by reference, and we'll receive the value by x. Okay. Now we'll write a traversal, no, not a traversal, a for loop that will run x times and load that many random values into the array. So int I equals 1, while I is less than or equal to x, I plus plus. And then every time we go through, we'll n.push back. So we will put a random item on the end. Let's go random modulus 100 plus 1. So that should load it. Of course, we're working with random numbers, so don't forget to put in your srand line. Okay, so after we load it, let's display it. So we'll write another one, display numbers, and void display, and we'll get our vector. And remember that it does not need the and sign here because we're not making any adjustments to the array inside this section. So all we're doing is displaying it. So this is where our traversal array is going to be, or for loop is going to show up. Well, I is less than n dot size, I plus plus. And then what we're going to do here is we're going to see out the value n, and we'll space them out with a space. When we're done, we'll end out. Okay, so now let's run the program and see what we've got. Okay, so this is our unsorted array. What selection sort is going to do is it's going to go through one item at a time and find the smallest value. So it's going to go 96, 98, 48, and then we'll go to the number 2. Now this will get stored as the smallest. So 96 will be the smallest, and then it will find 48 as the smallest, and then 2 is the smallest, and then it will go through all of the remaining values to see if anything is smaller than that 2. When it's done, it's going to take the 2 out and then put it into a new array. So what we're going to do for that is we will create a new function here, and I'm going to call it select sort, and we'll send it numbers. And then the other thing that we're going to do is afterwards we're going to display it again. So we're going to send the array to get sorted in the select sort function and then display it again afterwards, and it should be sorted. Okay. So in order to do this, we're going to need select sort vector int, and we need our and sign here because we are definitely going to be making some adjustments to it. Now we need a new one because we're going to be creating this new version and then replacing the old unsorted one with the new sorted version. We need to make a temp array here. Okay, so we've got our temp, and we are also going to need to keep track of a position. That is going to be the position of the smallest, and value. This is going to be the value of the smallest. Okay, and those are going to be pretty important. Okay. So what we're going to need to do is we'll be doing a while loop. And what we want to do is we want to keep doing this. We want to keep pulling elements out of the original array until it's empty. So what I want to do is I want to loop it when it's not empty. So the way we would write that statement is exclamation point not, which remember that reverses a true to a false or a false to a true. So while not n.empty, then we're going to do this. So while n.empty is false, so if it's false, that'll make this a true statement. So while this is the case, I want you to keep looping this loop. So here's what we've got to do. Number one, we have to find the smallest value in unsorted. So we're looking through the unsorted array to find the smallest value. Now, before we get started, let's just assume that maybe position 0 will be the smallest. So we'll just store that to get going. And our value is going to be n. Whatever value is in position 0 of our array. And then what we want to do is we'll do a traversal. So for int I equals 0. I'm keeping this at 0 just because that's kind of familiar, and doing it taking a look at that value one extra time isn't going to be a problem. Well, I is less than n dot size I plus plus. Now what we're going to do is we're going to check to see if the current value we're looking at is smaller than whatever we have stored. So if n(i), so if the current value that our loop is on is smaller than the value that we have stored, then we are going to do two things. Our value is going to become this new smaller value that we found. So again, this section is for new smallest found. And then the other thing is we're going to need to store the position that we found it at. So value will always hold the smallest value. Position will always hold the place that we found it. And that's going to be important in just a minute. So after we go through this, this will find the smallest value every single time. Now what we want to do is we want to add it to the sorted array. Now potentially, if this is the first time through the loop, Our sorted array has nothing, so we're just going to be including that. But we know how to add things to the end pretty easily, so temp.pushback. And we are going to take whatever value from n is currently at our position. So we're using the position value here. Now, why do we store the value here? The value at that position is only used to figure out if what we're looking at is a new, smaller value. So we don't need it after the loop is finished. And then we want to remove the value from the unsorted array. Now we know how to do this because if we're removing a value, that's going to be an erase function. So n.erase. Now the position that it is in, we're going to start at the beginning of the array and then move over this many positions. So we're taking the value that's at that position and we're adding it to the sorted array, and then we are removing that position from the original. Now, this is all it is. This goes over and over and over again. Now, the only thing that we have to do is, because temp will be a completely sorted array with all of the values, after our loop is done, we need to make our n get replaced by the temp. So our currently now empty array, because we've removed all its values already, is going to get replaced by the sorted array. And because we sent it by reference, the numbers in the main program will show that change. So we're going to run this. And here's what it does. It takes all of these values, so you can see the largest one is 100, shows up at the end. It looks like we've got a 2 and a couple 4s, so here's our 2. There's a couple 4s. So this is probably the easiest algorithm here to write. But yeah, it just takes the smallest value and continually adds it to a sorted array until you're done.